Good morning, class. I remain your favorite tutor, Adelu Peter. Today, I want to take us through scalars and vectors. But majorly today, we are going to be dwelling on vectors, vector quantities. But let me start with scalar quantities. What are scalar quantities? These are quantities that have magnitude but no direction. Scalar quantities are quantities that have magnitude but no direction. So scalar quantities are those with magnitude but no direction. Now, when we talk about magnitude, we are talking about numerical values. So scalars have numerical values, but they have no angle attached to them. An example of scalar include mass. We have mass. We have distance. We have speed. We have area. We have volume. You know them. So please, you can know the list is endless. We have density. What again? We have energy. We have electric potential. We have time. We have temperature. And so on and so forth. If you look at these quantities here, you cannot represent these quantities with angles. You can't tell me that the temperature of somebody is 30 degree northwest. Although we use degree for temperature, but degree Celsius. Degree Celsius is derived from that of from the degree we use for angles. So you can't tell me that the volume of a particular container is 30 meter cube at an angle 40 degree. So they don't have angles, they don't have the direction in which they act. So they only have magnitude. So these are examples of scalars. Now, when you talk about vectors, vector quantities are those that have magnitude and what? And directions. So this one have both magnitude and directions. For example, can we list examples of vector quantities? We have displacement. If you remember, the definition of displacement is distance traveled in a specified direction. So it means displacement has both magnitude and what? And direction. We have velocity. We have acceleration. What again? Force. We have weight. All these ones have directions. If you remember, the weight of every object always acts downward. That downward is direction. That downward is what? Direction. We have momentum. We have moment of a force. Moment of a force. You know, moments can either be in the clockwise direction or in the anti-clockwise direction. Okay. What again? We have electric field strength or intensity. Electric field strength is the same as electric field intensity, and so on and so forth. So these are examples of vector quantities. Now vectors are usually represented by what? By arrows. Vectors are usually represented by arrows. These arrows shows the direction in which the vectors are headed to. So there are 8 possible arrows, 8 possible directions in which vectors can what? Can face. This is east, if you remember your cardinal point. This is north. This is south, downward. This is what? West. This, now, from your cardinal point, this is north, this is east, this is west, and this is what? South. So if you have something in this direction, that's what? North, east. If you have something in this direction, that's, yeah, that's what? This one is north, west. Then here, this is what? Southeast, and this is what? Southwest. So making how many possible directions? 1, 2, 3, 4, 5, 6, 7, 8. So that is what we mean by direction. And you also be given the angles for these ones. You must indicate the angles. Okay. Now I want us to look at resultant of vectors. Now in this topic, we are going to be using vectors and forces interchangeably. We'll be using those two terms interchangeably. So we want to look at the resultant of two or more forces, or you call it vectors. Okay. Resultant. Now, what do we mean by resultant? The resultant of two or more forces is that single force which have the same effect both in magnitude and direction as those two or more forces put together. So that singular force that can replace two or more forces and we still have the same effect both in magnitude and direction as those two or more forces when they are what? Put together. That singular force is called the resultant of those forces. But how do you find resultant? Now, resultant, there's another term used for resultant. You can also call it net force. Net force. So they can ask you to find the net force of two or more forces. So, number one, let me just give examples. Let's look at the resultant of parallel forces. Resultant of parallel forces. Do you know the meaning of parallel forces? In mathematics, two lines are parallel if they can never meet. Two lines are parallel if they can never meet. So parallel lines are lines that can never meet. So when you have two parallel forces in the same direction, acting in the same direction, how do you find the resultant? If there's a particle here, this is a particle, so that you now have a force up here pulling the particle towards the right hand side here. Let me assume this 20 Newton. Then you have another force down here pulling in the same direction. Let me assume this 10 Newton. And you're asked to find the resultant of these two forces. You can see that these two forces are parallel to each other. So you are the resultant force F subscript R means resultant, while F stands for force. So let me call this one F1 and this one F2. So this is going to be F1 plus F2. So you find the sum. So if they are in the same direction, what do? Find the sum. So that sounds like a rhyme, okay? So that FR will be what? 20 plus 10. And that's going to give us 30 Newton. Now, this 30 Newton is just magnitude. This is just the magnitude. You are not done. If they ask to find the resultant, so you must express the resultant both in magnitude and direction. So what's the direction? So what will be the direction in which this particle will go? Definitely the particle will go in the eastern direction. So that we are going to write to what? To the east, or you say to the right hand side, to my right hand side, just like as I'm facing the board, to the right hand side, okay? So that is the resultant. So this looks like a rhyme. So when forces are in the same direction, how do you find the resultant? You find the what? The sum. So same direction, you find the sum. You add them together, add them up, okay? But what if we have them in different directions? That's scenario 2 now. Now, when I say different direction, I mean opposite direction. I'm using that different direction so that I can also use a rhyme for you to remember that. So different two forces, two parallel forces in different, that is opposite, directly opposite each other now. Different directions. So how do you find the resultant? So this is a particle again. And this particle is being acted upon by two forces, one to the right hand side and the other to the left hand side. Okay, assuming this to be 30 Newton and this one to be 20 Newton. So what do you think the resultant is going to be for these two forces? Okay, so resultant FR is going to be what? Now this time around you are going to find the what? The difference. Find the difference between the two forces since they are in different directions. So we are going to find the difference, meaning we subtract. In mathematics, difference means subtract. So this is going to be F1 minus F2. If I call this one F1 and this is what? F2. So that is going to be 30 minus 20. So please make sure you remove the smaller one from the bigger one. So this is going to be what? This is going to be 10 Newton. And this 10 Newton is to the west. That's to the left hand side. So this magnitude and this what? The direction. So the last one I'm going to give you, the last example. Okay, I think I should give two more examples. So you can see we just find the algebraic sum or algebraic difference between those forces that are acting parallel to each other for us to find their resultant. Okay? Example 3. What if we have three forces this time around acting on this particle? So that we have two forces to the right hand side here and only one to the left hand side. So let's assume this 15 Newton. Let's assume this 20 Newton and this also 20 Newton. So what do you think the resultant of this system of forces is going to be? Now, first find the resultant of these two. What is going to be the resultant? That's what? 20 plus 20. And that is going to give us 40. So let me redraw. I have something like this. So 20 plus 20, I have what now? I have 40 Newton to the right hand side, and this one still remains here. 15 Newton. So this one's not have been resolved to give 40 to the right hand side, and we still have this 15 Newton here. All right. Plus FR finally is going to be 40. We have these two now in opposite direction. These two in the same direction, 20 and 20. Okay. So this minus 15, and we are going to have 25 Newton. It's just like tug of war. I forgot to use that word here, tug of war. So at this 40 now, we drag this 15 to the right hand side. Imagine two opposing sides engaged in a tug of war. Definitely the ones that are stronger, we pull the ones that are weaker towards themselves. So 40 will pull 15 towards the right hand side, but the final effect is going to be what? 25 Newton. 25 Newton force is going to be felt by the particle at the middle, and it's going to be to the east, or you say to the right hand side. So that's the resultant. Then finally, what if you have two equal but opposite forces? Two equal but opposite forces. This 10 Newton and this 10 Newton. So how do you get about this? Resultant, which is FR, is going to be what? 10 minus 10. That's what? 0 Newton. This particle remains in the same position. It doesn't change. The particle doesn't change position. It's as if no force is acting on the particle. Okay? So please don't forget, this 25 Newton to the east will replace these three forces put together. This 0 Newton will replace these two 10 Newtons acting in opposite direction to each other. And definitely, this one has no direction since it is 0 force we have. So you can't say to the right and you can't say to the left. This 10 Newton will replace these two systems of forces acting in opposite direction to each other. So that's how you find the resultant of forces of forces that are parallel to each other. So please like, comment, and subscribe. You can even share with your friends. I'm going to be dropping the resultant of forces that are inclined at an angle to each other in my next video. Thank you.